watch because this time Pavlo, he didn't give you any example for the exercise. Am I correct? So do you have maybe any comments before I start? No? Hello, Sakurahman. What are you doing exactly? Why you are so loud? Okay, I'm going to start then. So yeah, for module four, we're going to discuss about the query. At least I hope you watched the video, so I don't have to explain like a lot about because the video actually were about the basic fundamentals or basic theory of about the queuing itself, something that maybe you already familiar with because it happens all the time in our daily life. So here it's some the explanation, but I'm not going to be very detailed on it. So I'm just going to showing you this. So this is basically the fundamental concept about the queuing theory. So let's say this is a condition where when you go to the bank, for example, so you are a customer and then you enter the bank, and after that you're about to meet the teller so to do some transaction or something like that, but it's full at the moment. I mean, like all the tellers. So here, for example, the bank has four tellers, and it's in this part it denote as server or as. Let's say that the bank has four tellers, but all of them are being occupied at the moment. So you have to wait in the queuing, or maybe in seat somewhere. And after that, when your number is being called, you go to the teller, one of them, and then finish your transaction or your any other business, and then you leave the bank. So these kind of things is basically what we are going to discuss or cover up during this chapter or during this module. Okay, and so it is called as queue because you have to wait for being served. So we're going to focus on it. And there's also another condition called as bulking. So this is a condition when, for example, you went to the bank and the queuing is too long, and then you're start boring, and then you upset, and then you leave the bank. So this is the condition, like the customer needing service, you refuse joining the queuing, so you leave the bank because like you are upset and it's too long, the service is not really good, or maybe some other reason, or in another terms, you walk out, just leave the place. In queuing discipline, so this is something that, well, maybe some of the terms you are already familiar with from scheduling system, the thing that we have learned from PSA. So in queuing, yes, there's also some disciplines or methods. The first one is first come, first serve. So this is or first in, first out. Yes, I guess you're already familiar with this. And random selection process, this is something that pick randomly, that so there's no any patterns about the sequence, or I would say this is kind of discrete because it's just like taking randomly. Or in another discipline, it is also the condition about the LIFO, or last in, first out. And there's another terms in here like reneging. So this is one of the example. This is another example rather, and it's different with bulking. So in bulking, something that in here. So in bulking, so you just leave, like you just leave and you don't come back. But in reneging, so you leave the queue okay, and then you join again. So that's the difference between bulky and predicting. And well, this is just some of the example, but the service mechanism. So in any cases, like the persons or the object that going to serve you, it is called a server. So for example, in the illustration about the bank, the teller is called as a server, and the person or the object that being served, it is called as customer. Well, I think you're already familiar with this. Yeah, so that's basically about the introduction. And here, this is actually the way we wrote. So you're going to recognize like 3D nodes in here, where the first one is inter-arrival times, and the second is service times, and the latest one is number of server. But I'm not going to be very detailed on it because it has a lot of notation, as you can see in here, but and we're going to cover this up during this module. So, but at the moment, at least for this meeting, we're not going to discuss it. So you don't have to worry, you don't have to be like overwhelmed where there are like a lot of things to be learned today. No, so I'm just gonna skip this, and we're going to discuss more in here because we have to be familiar with a lot of notations and a lot of symbols that will be appear during this module 4. Okay, at least for today, because some of them, well, there's a lot in here, but we're not going to cover all of them today. At least, for example, like this part and this part, we're not going to cover for this meeting. So I'm just going to let you know something that you need to be familiar with, at least for today. So okay, this one here is the first one that you have to memorize in your mind. So Pn and T is probability of exactly. So that's and okay. So here remember, S is the server and N is the customer. Okay, so it just because S means server, it doesn't mean that customer denote as C. No, N is the number of the customer. So here, as you can see, PNT is actually probability of exactly N customer. So probability that customer will be in the system at the specific time. As is parallel servers in the system, for example, like tellers or cashier in the supermarket. And the next one, something that you have to familiar with is lambda n. It's a mean arrival rate, or it is written in here, average number of customers joining QE per unit of time. So we're speaking about number of customers in here, okay? But in average, like joining the QE, waiting to be served time. But in this condition, you know exactly like how many customers, okay? So you know, for example, like we have 4 customers at the moment. So here, for example, like and equal with 4, like we have 4 customers, but we just want to know like what is the average. And mu n is mean service rate for overall system, or average number of customer completing service per unit of time. So it's going to be, the unit scale in here will be in time. So it could be like 2 minutes, 1 minute, or something like that. That's for at least some notation. Moving on, something that you have to be familiar also about, okay, these first 2 things, okay? Okay, let's see it first in here. So L is expected number of customer in the system. Okay, so we're speaking about like, okay, what is exactly the expected number of customer that will be in the system? So there will be a different, okay? So here, if we are speaking about system, if we are speaking about system, it will be both, okay? So object that's still in the queuing and object that being served, okay? So if I can go back again in here and back again to the illustration. So like system is the entire scenario, okay? So all of them, it is called as system, where inside there are two, it will be divided into two conditions. The first one that being in a queue, and the second one it's being served, okay? Back again in here. Yep, both in the queuing, waiting for service, and then being served. And here's the formula. So remember, N is customer. It will be times probability for each of the customer, the sum up of them. And the next one is LQ. So Q, remember Q is always represent, yeah, Q represent the queue, antrian. So LQ is the symbol for the expected queuing length. Like, but it's not, it's exclude that customer being served. So it is purely just calculate the queue. Okay, so remember, once again, system is covering both, like the queuing and also being service. But in LQ, you just have to calculate person that in queuing, or in other words, I can say that not being served yet. And here's the formula, like remember, N is customer minus number of servers and then times probability for each case. Okay, that's it. And the other things that you have to be familiar is the little formula. So here's also another way to calculate. So the difference is just because here you have to consider the probability. Okay, you have to consider the probability. Uh, if you don't know exactly, or for example, the information is not given about the probability, you can use this formula instead to find the L and also to find the LQ. So remember, if you're still familiar, lambda is, let's go back again, is the mean arrival rate. Sometimes, I mean, like most of them, like the value is given and then times W. Here we can see the W is the expected waiting time in the system. Okay, so remember, at least today there will be 4 important notation that you need to know. Okay, if here we're speaking, if it's L, we're speaking about number of customer in the system. In LQ, we're speaking about number of customer in the queuing. Okay, and W is represent the time. So W is expected waiting time. Waiting time in the system, but WQ is waiting time in queuing. Okay, so here is the formula, but if you know that there is a mean service time is constant, it means that all the service can serve the customer in the same duration of time, and the symbol is 1/mu. Then to find the W, you have to use this formula instead. But I believe that you still don't have any idea about what I'm speaking about because the example is not given to you. So I'm going to guide you to work for our first exercise. But before that, do you have any questions at least about the formula, about the basic theory of the queuing itself? Is there any question, something that you need to ask for? Not yet, tapi rumusnya lumayan. I'm going to tell you that for this last two modules that like queuing theory and also inventory theory, like the symbols or the notation, it will be a lot, and there will be a lot of variants also for formula, not to mention that PSA itself also has a lot of formula at the moment. So I mean, like, I'm not going to scare you, but just prepare yourself for the rest of the semester. Okay. Thank you, Husna and Alok. If you don't have any questions, let's see here. I'm not going to ask you like, okay, work for this. No, not at the moment. I just want to let you know that and make you more familiar about this case. All right. Newell and Jeff are two barbers in a barber shop they own and operate. They provide two chairs, okay, for customers who are waiting to begin a haircut. So as from this illustration, you can get the idea like server or S is equal with 2. Why? Because they are two barbers and they have like two chairs. So it means that they can serve two customers at the same time. So server is equal to 2. So the number of customers in the shop varies between 0 and 4. So if you're wondering like, okay, number of customers, but why we need to include 0? So 0 is the condition when there is no customer at all. So here, something that you have to keep in your mind. So n, let's always start with 0, not start with 1. Even though we're speaking about the object in here, which is a customer or can be associated with a person, but it should start with 0. It's always start with 0 because this will be a condition where there is no customer at all in the system at that moment. So it could be infinity. So that's why here we have n start from 0 until 4, and the probability is given. Okay, Pn for probability for if there is no customer, we have 1 customer, 2 customer, 3 customer, and 4 customers. So what do we have to do now? First thing that I always ask you for is to gather the information. Let's see here. We have 2 servers and then n, or remember it's always starts with 0. Here is our customers, and we have probability as well. P0 is 1/16, P1 and P4 is 1/16. Back again to the questions is, so calculate L. So we need to find L. And how would you describe the meaning of L to Newell and Jeff? So let's see. Let's work for the first case. So remember, L is the expected number of customers in the system. So it will be both, like the person that the customers that being served, and also the customer that still waiting to be served. And here remember the formula is the sigma start with 0 until infinity, and number of customers times the probability. So here we start with 0. Probability of 0 is 1/16 plus 1, 4/16, and 2, 6/16. Here, if we have 3 customers, over 16, and 4 is 1/16. So if you do the calculation, the result will be 2 customers. So what does it mean? It means that this is the expected number of the customer in the system. So it means that there will be like the highest probability that there will be customers in their shop, both that being served and also still waiting. Probably most of them, or most of the case, it will be 2 customers at the same time. Questions about L? Any questions? Clear enough? Okay, thank you, Ifat. If there's no questions, thank you, Diony, Savannah. Let's go back again. Okay, so we finished with A. Let's moving on to part B. For each of the possible value of the number of customers in the queuing system, specify how many customers in the queuing. So the thing that being asked is clearly in here. We need to calculate the LQ. And what exactly, what does it mean actually for that, for Newell and Jeff? So the second one, we need to find the LQ, expected number of the customer in the queuing. Remember the formula is sigma of n times S probability times the probability of the customer. Well, usually you can create a table in here. So the first one is customer, the second one in the customer in the queuing, and then the probability, and the second is the product or the result from the multiplication. So remember we have this case for the customers, okay? Okay, and the second thing that you need to figure out, like how many persons in the queuing. So here, if there is no customer, so it means that there is no persons in the queuing. So here it's 0. Of course, the probability also will be 0. And remember, there are 2 servers, okay? So if it's n equal with 1, and the person in the queuing also will be 0, because we have 2 servers in here. And it's the same, this one is also 0, but if we have 3 customers and there are 2 servers, so it means that there will be 1 person in the queuing in here. And the same for if we have 2 customers, sorry, we have 4 customers, that it will be 2 customers in the queuing. And here you just can rewrite again the probability it's given from the previous part. And here you just can multiply, like 1 times 0.25 is 0.25, and 0.6 25 times 2. This one will be 1 to 5. Okay. And to find the LQ, you just simply can sum up this thing. So LQ is 0.25 plus 0.125. The result will be 0 from 375. So it means that this is the expected number of customers that will be in the queuing. If you see the value like 0.375, we can, it's going to be the same with 0. So it means that actually there will be no person waiting in the queuing. Why? As you can see in here, like the expected customer of the system is actually 2 customers, and we have 2 servers. So it means that when we have this number of customers, it will be served directly. So there's no any reason, or if there is any, it will be in a small probability that there will be a customer that needs to be wait before being served. Okay, questions?
Miss, I think the multiplication is wrong, Miss.
Yes,
Yes,
gimana Ade? Yes, Ade?
The 2 times 0.625 is 1.25, Miss.
1.25.
25.
Oh, sorry, it's not this one. 0.0625. My mistake.
Oh, yeah. That
Yeah.
is correct.
Yep, because this one, thank you so much, Ade, for, let me see my mistake. This one is from 6/16. So 0.625 times 2, and it will be 0.125. Okay, is that correct now?
Yeah, already.
I think no, Miss. Because
Thank you, Ade. Sorry, Diani.
Miss, saya masih belum paham yang kenapa saat customernya 3 yang di antriannya 1. Terus waktu di customernya 4 antriannya 2. Saya masih belum paham tentang itu. Mungkin boleh dijelaskan kembali.
Okay, thank you, Diani. Okay, so back again, if you still remember the illustration given that it has, I'm going to catch up back in here. Okay, they provide 2 chairs for customers, okay? And it means that, okay, I should wait to, yeah. So server is 2, so it means that, let's say they have 2 chairs in the barber shop, okay? And let's say there are 3 customers coming, want to cut their hair. The first customer will go into this chair, this one going to this chair. So this is one person that should be wait, okay? So here, that's why person in the queuing is 1. Got it? Get the idea?
Yeah, I got it now, Miss.
Okay, so that's...
Thank you.
And let's say, okay, there's another person come to here, the customer number 4. Well, this 2 are being served. Okay, here, this one is also need to wait. Now we have 2, so here is the result why we have 2 persons in the queuing when the customer is 4. Thank you for the questions, Diani. Is there any questions? I heard that there was a lot of there are voices coming from other people previously. Is there any other
Miss,
questions?
I have a question, Miss. Can you hear?
Farida? Farida?
Yes.
Okay.
Yes, Miss. Actually, I wanna ask if the n is 0, it in queuing, in number of queuing is always 0, right, Miss?
Yeah.
Because
your
yeah. Yes.
Yes, because there is no person coming at the barber shop at that time, so there's no queuing at all.
Okay, Miss. Thank you, Miss.
Okay, just to make sure that you also get the idea why this if customer 1 is the queuing is 0, why customer 2 is 0? Because yeah, for this case that okay, we have 2 chairs and there is 1 customer coming and they will go serve directly. So there is no any queuing behind them. So that's why here queuing is also 0. Thank you, Farida.
Miss,
Yeah.
I have some correction, Miss. Actually, for 0.0625 is the result of 1 over 16, Miss, not
Oh
6
yeah,
over. Yeah. Thank you,
yeah,
Miss.
over 16. Oh my God, thank you so much, Farida. Yes, it's 1 over 16. Thank you for the corrections anyway. Any other questions, at least for L and also LQ? Clear enough so far? Okay, if there's no questions, let's move on to part C. So determine the expected number of customers being served. So it means that you have to find the probability if there is a customer. So back again in this scenario. Okay. So here is the condition when we have 1 customer, 2 customer, 3 customer, 4 customer. So you have to find the expected again in here, but you don't have to, but you will not include this part, okay? Because this is probability is equal with 0, so it means that there will be no customer that being served at that moment. Back again to the questions, determine the expected number of customer is being served. So I'm going to write down in here. So you just have to find by using the probability again. So we start with P1. If there is 1 customer, it will be 4 over 16, and then plus here it's 2. Okay. Okay, well, actually this one is 1, but we simply don't have to write of that, okay? This one is P2 when there are 2 customers being served, okay? Remember the word is being served. So they let's say that that's the condition when there are customer like sitting in the chair being served, okay? Here is 6 over 16. And the next one is if it's P3, the probability is 4 over 16. But here, when there are 3 customers, let's say there are 3 customers, the ones that being served is still 2. Okay, so it doesn't mean that, okay, it's going to be plus 3, 4 over 16. No, it's not going to be like that, okay? So because even though we have 3 customers, it will be in the same value that even though we have 3 customers in total, but still there will be only 2 customers that being served. So you can include the probability in this bracket here 4 over 16, and that's the same case if there are 4 customers. Also, there will be just 2 that being served here. Okay, so if you do the math, it's 13 over 8, okay, and it's going to be 1.625, or if we want to convert to integer value, it will be 2 customers, which is clear enough. There will be 2 customers that being served because why? Because because the barber shop has like 2 chairs, so they can have like maximum 2 customers that being served. Clear? Clear or not clear?
Miss,
Yeah.
I want to ask something about the rounded list. It is kan 1,625 itu bakal di round jadi 2 itu apakah nanti kalau misalkan dia case-nya 1,1 there will be 2 people or 1 people, Miss?
There will be 1 people. So remember the concept of round up, round down, the one that we applied in PSA. It will be applied the same in here.
Thank you, Miss.
Okay, thank you, Dila. But anyway, speaking about PMOR, because we speaking more about mathematical way in here, later on when you do your homework or you do your exercise, it's okay. You don't have to like convert to integer all the time. If you just show the value like this, well, that will be okay as well. If it's in PMOR, but in PSA, it's always should be in integer. But if you talk about that, is that should be round up or round down? But basically, I'm just showing you that this analogical thing, so you have no idea. So you have idea. Okay, so 1.625 is the same with customer, simply because if we draw the illustration also in a simple way, because well, the barbershop has 2 seats, so they can serve like 2 customers at the same time. That's it. Any other questions? Clear enough? If there is no questions, thank you, Savannah and Dila. Okay, let's continue to another questions then. Part D. Give that an average, okay, average of 4 customers. So we have new information in here. It's a lambda will be equal with 4. Remember, average number of customer, it's lambda. Per hour arrive and stay to receive a haircut. So we need to find W and WQ and describe these 2 quantities. Well, what does it mean for W and WQ? So back again to the formula. So here we have, so we know the value of lambda, so we have our L and our LQ as well. So you can use this little formula to find the W and also WQ. So here you just can also change the formula up to WL over lambda, and this part is WQ is LQ over lambda. Let's see how does it work. WQ, sorry, we need to start with W instead. It's W is L over lambda, so 2 over 4 here, 0.5 hours, or equal with 30 minutes. And WQ is LQ over lambda. Remember, the LQ is 0.375 over 4, and it's going to be 0.094 hours, or more or less like 6 minutes. Okay, so what does it mean actually? So it means that the total time that the customer will be in barber shop is 30 minutes. So for example, that you guys go to barber shop and you spend the total time inside the shop is up to 30 minutes. and the total time in queuing, the duration will be approximately 5 minutes, or no longer than 6 minutes, if I would say. Right? Well, so that doesn't mean for W and WQ. It's the total time in the system. So it means that this is the total time for the be in the barber shop, and they will have to wait for 5 minutes, or I would say that no longer than 6 minutes before being served in the barber shop. Questions about WQ? No questions? If there's no questions, the last part is, given that Newell and Jeff are equally fast in giving haircuts, what is the average duration of a haircut? So this is just easy because we need to find so for how long actually the hair will be cut anyway. So here is, you just have to subtract W times WQ. It's 30 minutes, subtract with 5.625, and the result will be 24.36 minutes. So it means that it will be more or less 24 minutes that the hair will be cut. Whether it's being cut, you need to wash before, or give the customer pomades, or something like that. The total time being in the service will be 24. Okay. Any questions? Okay, question from Farida. For one customer or the two, which one actually that you're specifically asked?
Sorry, Miss. I think I think that it is for one customer or two, Miss, because when you not said the how many customer that waiting for 30 minutes or 5 minutes.
Mm-hmm.
I'm wondering
okay.
about.
Okay, so for this, for which customers this case actually? It's in general, or I would say it's an average. Why is an average? Because we use lambda in here. Remember, lambda is the average arrival rate. So it's in general. So whether the case will be one customer or two customers, even they have more than two customers, but in general way, that the result will be like this. No matter the will be, because it's in lambda, it's in average. All right.
Okay, Miss. I got it. Thank you, Miss.
Okay, thank you, Farida. Is there any other questions? No questions? Is that clear enough? Okay, thank you, Dila. If there is no questions, well, I hope this from this case or from this example, you can have the idea about well, at least the basic mathematical way of queuing theory itself. So let's move on to exercise, the real exercise that you have to work on your own. So Midtown Bank always has two tellers on duty. So you can get the idea, this is the number of the server. Customers arrive to receive service from a teller at a mean rate. Okay, we have mean rate in here, 40 per hour. And the teller requires average of 2 minutes to serve a customer. So remember here, average, but specifically to serve a customer. When both tellers are busy, arriving customers join a single line to wait for service. And experience has shown that customers wait in line in average for 1 minute before the service begins. So there are some information. I think two of these things you already familiar with. But this one is mean rate is 40 hours, so it means the lambda equal with 40. And here the average of 2 minutes to serve as a customer, so it means that this one is 1 over mu. Okay, 1 over mu is 2 minutes. Remember, average duration of being served. Okay, the question is part A. Describe why it is a queuing system. Well, simply this is not. You don't have to answer these questions with numbers or by doing the calculation. This is a queuing system because there are servers and there are customers. So basically, the answer is just like that. So let's skip part A because it's clear enough, and moving on to part B. Determine the basic nature of performance. Okay, please find these things. You have the information. If you, okay, the clue is because we know the lambda, there's no probability, so you can solve these things by using little formulas. Okay, I think 10 minutes maximum will be enough. So try to solve this problem. If you have any questions, just let me know. Okay, has anyone finished? Get the answer? Has anyone finished? At least to one of them, maybe you find the L or find the LQ or W or WQ.
Starting in.
Okay, anyone get the result yet? Or not? Or have? Okay, question from Ade. Is it true that WQ is 1? Yeah, that's the truth because it's given, yeah. But it's just I didn't give you the symbol. What is it actually? So yes, WQ is 1. No, Dila, WQ is 1. W is, yeah, but W is 3 minutes. So you're correct. Thank you. So after that you can find, yes, thank you, Ade. W is 3 minutes. So if you find the W and WQ, so you can continue with L and also LQ. Anyone get the same result with Ade and also Dila? So remember, we always need to define the data first, so it will be easy for you to find the result. So server, we have 2 servers. Lambda is 40, and then 1 over mu is 2 minutes. All right, and yep, WQ actually it's given, yeah, so it's 1 minute. Here in minutes, this one also in minutes. So if you remember the formula or the basic form of little formula is L is lambda over W, LQ is lambda WQ, and W is WQ plus 1 over mu, this one. Because the thing that given actually is WQ and 1 over mu, so you can start with W. W is okay, WQ plus 1 over mu, so simply just 1 plus 2. It will be 3 minutes. Okay, L is 40. Are you sure that L is 40? We're speaking about customers in here, not time. So 40 and 120, unfortunately, that's not correct. Okay. So remember guys, this is the formula. So LQ is lambda times WG. So, but here, remember this one in 40 minutes. So 40 minutes over 60 because we have 60 minutes in 1 hour. Okay? And then times 1. So then you can figure out the result. And then the same with L as well. As Okay, lambda is 40, but we have 60 minutes in 1 hour. And here times 3. Okay, so you get the result then. Remember, L and LQ, we're speaking about object, we're speaking about customer in here, so it's impossible if it's if the result will be in hundreds. All right, where the server is only 2 and the customer is 120. It's simply not not possible. So yes, you use the wrong formula, but that's okay. Okay, let's see. Answer from Dila. L is 2 and LQ is 4/3. Yep, that's correct. Any other question? Any other questions? Do you have the same results? But are you sure that LQ is 4/3? I'm not sure the LQ is the correct one. Okay, 4/6. Well, thank you. And do you get the same answers? Tila, why are you raising your hand virtually?
Kepencet, Miss, maaf.
That's okay. Anyone get the same result with Tila's? Okay, thank you, Diani. So LQ, okay, simply you have to calculate the LQ firstly because we need that, well, actually, you can start with LQ or with L. Let me see. It's, okay, Dila said that 4/6 or 0.667 customers. Okay. And for L, simply it's 2 customers. So it means in the teller bank, like because they have 2 servers and there will be 2 customers for both in the system for being served and also waiting, and it will be LQ approximately 0.667 customers, and the total time being in the system is 3 minutes, and being in the queuing is 1 minute. So we can assume that the duration of being served is 3 minus 1 is 2 minutes approximately. So it means that the customers will being served by tellers approximately within 2 minutes. Okay. LQ is 1 customer. Yeah, that's the correct one if you convert to integer value. Thank you, Farida. That's also the correct answers. So that's it. That's how to find the expected number of customers in the system, in the queuing, and then find the durations as well, being in the system, being served, and also being in the queuing. Remember, if the probability is given, so you can simply just use the sum up of n times pn, but if the probability is not given, but the average rate is given, so you can also use the Little's formula to find the results. Questions? Well, I hope it's easy for you, at least for today, it's easy. But still, do you have any questions? Something that you don't understand clearly? Something that needs to be re-explained? Any questions?
So, Miss, I want to make this clear, Miss. So why it's divided by 60? Because we use 40 as the rate, and the rate is in per hour, right, Miss? So we need to convert it to hour too. Something like that, Miss.
Yep, exactly. That's the
Okay.
correct one.
Thank you.
Because here is 40 per hour. Okay. So yeah, that's why you have to divide it by 60 because we have 60 minutes in 1 hour. Thank you, Farida. That's a very clear clarifications. Is there any questions? Any comments? Something that you also need to clarify? Is that clear enough? Well, I think that's clear enough for you. Well, because actually it's easy. At least for this moment, it's still easy. So if you can understand this part clearly, I'm pretty sure that you can also keep up for the next material in this module. So if there's no more questions, then we can finish earlier today. Thank you so much. And don't forget to work for your homework. There'll be another homework. The deadline is on Monday. And start studying because we're going to have our quiz 3 next Tuesday. So please be online at least 5 minutes before 8 a.m. So I can share the questions promptly at 8 o'clock. If there's no more questions, then thank you so much. I'll see most of you tomorrow at PSA. And for those who don't take PSA this semester, so I'll see you then next week. Thank you so much. Have a good day. Bye.
Thank you, Miss.
Thank you, Miss.
Thank you, guys.
Thank you, Miss.
Thank you.
Thanks.